saying this ones which we have labeled 3, this for instance has a plus, this has a plus, and this has a minus sign. Now I've pulled this again, this identification has been made, this rewritten in this form, and that is what we've got here. Yeah. And so we have minus this plus that. Now what all we're trying to do is to try to make this differential, these three differentials, all the same. So we're going to do every kind of dummy variable interchange or change that will make these three differentials the same for all three terms, so we can pull it out in a bracket. We have used this, for instance, here now as our standard. You can see I have the x prime rho, the x mu, the x prime beta, the sk, the s prime gamma, the x nu. I want all these other terms here to look like this. If it is possible, of course, we can make that happen. Now here we already have the s prime rho, the x mu. We're in luck. I guess we don't have to make any further changes. But now you can see that the x prime eta, the xk. So what do I do? Very simply here for this case, I just have to change eta to beta. I can do that because eta occurred twice. Otherwise, I won't be able to do that. So if I do that, you can see that for this term, I will be left here with the x prime beta over the xk. Now again, I have sigma here, but the x prime sigma over the x, or the x prime sigma the x nu, instead of the x prime gamma the x nu. So I change the sigma here to what? Gamma. And of course, you can see I can do that because it's a dummy index, it occurred twice. But anytime I'm doing this, the change also affects this other accompanying factor. So for instance, if I am changing eta to beta, the eta here also has to change to beta. If I'm changing this sigma to gamma, the sigma here also has to change to gamma. So with this transformation performed on this term, these three differentials become the same with this. Now if I look at this other one here, you can see, of course, I guess, maybe we're in luck too with the middle one, the x prime beta, the sk, is exactly the same thing here. But it's not the same when I talk about, for instance, the x prime sigma, the x nu. It should be the x prime gamma, the x nu. But can I make that happen? Yes, this is a sigma, this is another sigma, so it's a dummy index. I can just straight out change it to anything else that I like. In this case, I'm making it gamma because that's what I want. Well, but I have a gamma here already, which is over the x mu, but I want that to be the x prime rho. So I change the gamma to rho. Again, remember, as we're making these changes, wherever any of these indices occur here, like for instance, I'll be changing gamma to rho, so this means that this gamma here has to be rho. And if I'm changing sigma to gamma, I wouldn't just be changing this alone, but this too. Now I'm doing all this together, you can see, of course, this time around I decided to pull out a minus sign, so this remains a plus, but these two terms that were originally plus inherit minus signs, and then these are all, I've pulled them all out the same. With the changes which I stated should be carried out. Here we changed sigma to gamma, so we have the gamma here. And here we changed our gamma to, what was that, rho. And so this is why we have a rho here. And I remember this sigma we changed to gamma, and that is what we've got here. Now, of course, this remains the same because this was what we used as our reference. We made no changes here. Everything here was the same, all right from the beginning. So this is just all we have here. Well. It's beginning to look like something we can work with. But now looking at this, we remember that what we intended to calculate, or you can say, everything that is left from here to the beginning, remember what we intended to calculate in the beginning was, or what we actually calculated was this. This, the x mu, the x nu. And remember, we also said we should, or we intend to calculate this too, whereby we interchange the k and the nu, the x mu, the xk. We intended to do this, right? So now what we intend to do is, of course, we gave an expression which we had made from, by interchanging the one for this initially. Obviously, we wouldn't be needing that. We can simply make that same interchange right away from this particular term here. So in this expression, in order to obtain this particular expression, or this particular differential here, all we'll have to do again is to perform the same interchange. So like we've said, remember that what we've got here is this. Now what we want to obtain is that. So all I have to do is to write this equal to whatever I've got on the right hand side. I make this interchange between k and nu. So wherever I see k, I put nu. Wherever I see nu, I put k. That's all we've got here. Everything written that way. Of course, you can see k nu here, whereas right here from the beginning, what we had was nu k. And here we have mu nu, but then here it becomes mu k. So you can just follow that all through, and that is all we have done to obtain this following result. Everything we have done so far to this point. That's what we've got. Okay, now remember at this point what we said is we intend to find the difference between these two. Of course, between this term here on the left hand side and what we have originally calculated this to be, which was this originally, the difference between those two is 0 because we said that partial derivatives commute and they are all the same. So what we want to do is simply just go straight ahead in computing what we have. So we can see already that from the left hand side we have a 0 because that's what it's going to give us. So the left hand side gives us 0. So equal to what do we have on the right hand side? Now looking at the right hand side, we have the x prime gamma tau, the x alpha. This is the same for this particular differential. There is nothing different. So we can just put that out like some factor that is common to all. Now in the bracket, what do we have? These two are not exactly the same. And you can see that this, for instance, is this mu, and that is nu, and this is the xk. This minuses, what we've got over there is the gamma alpha mu k, the x nu. And then, of course, here we've got plus gamma mu nu lambda, and then another gamma here, alpha k lambda minus mu k gamma alpha nu lambda. Yeah, we can see, of course, that none of these comfortably cancel because they are just not the same. But something remarkable happens with the next line. Everything here actually has one way or the other connected in one of these. All of these factors are the same except for a sign difference. Because of course when we say this term minus that, we are going to have plus plus on every side here. However, you can take note that these terms that we are labeling, this one here for instance, we label this one, we also label this one. Of course when we perform the difference, this will become a plus. But you can see that I have the s prime rho, the xk, the s prime rho, the sk, that gamma mu, gamma lambda mu nu, gamma lambda nu mu. Of course, this they are commutative, like we said, for the lower indices, for the affine connection or Christoffel symbol. So this term here cancels with this one. Now, if you look at again the ones we have labeled 2, we have a minus sign here. And by the way, of course, we have the same thing exactly what we've got outside here, the same for this time. Our interchange of nu and k haven't changed anything at all for the terms outside or the factor outside. So this which we have labeled 2, you can see the s prime rho, the x nu. Now I've got here with me the s prime rho, the x nu. Again, and all we've got here is gamma lambda mu k, gamma lambda k mu. Again, this one here cancels this, and you can confirm, of course, that this also cancels that. And that is what we've got for the second line there. The whole thing goes. Now the third line, we intend to do something different. What do we want to do? We want to perform a difference. Again, we want to have a situation whereby the differentials are the same. We're just thinking if we can. After all, we had that for this case. We have both the s prime tau, the x alpha, and the x prime tau, the x alpha. So, but if you look at this particular last term here, I have the s prime rho, the s mu, but that's just about that. It's the same thing for this here. However, the s prime beta, the x nu, but the s prime beta here, the sk, so they're not the same. How do we make that the same? Of course, turns out we're in luck. We could do that interchanging beta and gamma. We can do that because for each of these factors, you can see that they are dummy indices. If we were to expand all this, they all occur twice in each of the terms, and we can perform this transformation. If we did that, then of course I'll have the S prime gamma, the SK, which is the same as the S prime gamma, the SK here. And then, of course, this will become the S prime, what is it called, beta, the X nu. And that's what I'm going to have here. However, again, remember that whenever you're performing this transformation on any factor, it affects the same transformation, or it affects whatever factor that is multiplying it. So wherever I see beta here on this right hand side, which is multiplying this factor, I have to change it to gamma. And wherever I see gamma, I have to change it to beta. So if I am to do that, it therefore means I'm going to take a difference. Now, I'm just going to write straightforward. Remember, we are doing this minus that. So I'm going to take a situation whereby the plus sign is what I have outside. Remember, again, this we are leaving the same. This is the X prime here. Or maybe fine. Oh, well, no problem. We can settle down. It's just a matter of conversion. The X prime beta, the X nu, the S prime gamma, the SK. Again, remember what we said, we are doing this minus this. So I expect on the right hand side here, the S prime tau, rho gamma, the X beta, prime beta, sorry, the S prime beta. Now it will be taking a minus of what we've got here. However, remember, if it weren't for the transformations we made, they will have exactly cancelled. But remember, we made the transformations such that this will become the gamma prime tau. But then instead of just rho gamma, I'll have that to be rho beta, right? I guess that was the transformation we made. We said that the gamma should become beta and beta should become gamma. And this will become the X prime gamma. That's what we've got. And then the second term here, of course, yeah, so the one with the plus again remains this. Oh, no, this doesn't have a plus, so I'm going to be careful with the one with the plus, because if I were to take the difference between this and this, yes, this would be the one with the plus, and that would be minus. However, this minus originally would make this a plus, so the difference will indeed make, at this point in time, because this now will be the one with the plus. So let me start the one with the plus. So this will be plus the gamma here. Now, but then we should take note of the fact that, okay, this is prime tau, and what we've got there is going to be delta, but beta. Remember, because it was on this particular term here that we made this transformation. And now here I've got gamma, delta, gamma, rho. Yeah, that is what we've got. Now this is what we've got for this, and then it's going to be minus. Finally, we did this, which we are not changing because we didn't perform any transformation on this one. Gamma, and this is prime delta, and this is beta rho. Do they look the same in any way? They don't. Yes, because this tau here has delta beta, this tau here has delta gamma. And here we've got gamma rho, but here now I've got beta gamma. These two are just not the same. They can't cancel, and that's it. Now what about this? Of course, when I perform this transformation here, this particular term here becomes this, or factor. You can see, of course, it's still rho sigma, but then prime sigma. I've got gamma beta. So you can see that the only difference between this and that, before and after the transformation, was the interchange of these two for the lower indices of that affine connector, which we say never really changes a thing. And if you look at this last term here, they are just the same. This is rho sigma tau, this is rho sigma tau. I've got beta gamma sigma, beta gamma or gamma beta sigma. So these two terms cancel. And what we've got is just that. That is what we've got left together here. Looking at these, of course, like I was trying to avoid, but it's no big deal. I guess we are already close to. What we can do is just take one outside the bracket and the other. So cleaning this part of the board, we proceed toss. Going to do? We're going to take this, I don't know, well, let's choose this. We take this to the left-hand side. Of course, we should get a resulting minus sign, but I'm going to be making that change for this. So for instance, I'm going to have, let me say some minus the x prime tau. I'm guessing that is alpha on the other side. Yes. So the gamma alpha mu nu, the xk. And next, I'm going to have minus the gamma. Over there is alpha mu k. The x, I'm guessing nu. And next is going to be plus gamma. What have I got here? That is lambda mu nu and gamma alpha k lambda. Alpha k lambda. Of course, we've got that minusing gamma here, lambda mu k, and gamma here, alpha nu lambda. Alpha nu lambda. This is what we've got. This is supposed to be equal to. Now, okay, well, let me just copy out the differentials first. This is going to be the x prime rho, the x mu, and now this is the x prime beta, the x nu, and then this is the x prime gamma, the x kappa, right? Now, of course, I want to make an interchange. I want to just straight ahead without, so that I won't have to rewrite this. I want to multiply the minus sign out, so I'm going to put this first and later on make it. So this is going to be the gamma prime tau, rho beta, the x prime gamma. This is all to take out the undesirable minus sign out here by multiplying it. And now I'm going to have this to be minus, of course, written already. But that will be gamma rho gamma in that form. And what I've got here is the x prime beta. Of course, at this time around it becomes plus gamma prime tau delta gamma, and the next thing I've got is delta here, beta gamma minus is going to be this gamma, and I'm going to highlight here this, and also yeah, so this is delta beta, this is going to be prime of delta, and the next thing I've got is gamma rho. Gamma rho. That is what I have. Oh, of course, I think what is to be done here becomes obvious. So this gives us here this mu nu, the xk minus. So I'm going to be multiplying both sides with the inverse of that. Mu k, the x nu, plus mu nu alpha k lambda minus lambda mu k alpha nu lambda, and this is the same thing as the x alpha, the x prime tau, but then the x prime rho, the x mu, the x prime beta, the x nu, and here the x prime gamma, the xk, multiplied by this rho gamma, the s prime beta, plus tau delta gamma, delta beta gamma, minus tau delta beta, delta here, gamma rho. And of course, this all rings a bell. And we can see that this could be written as some sort of object, which we could say this implies R, reminiscing what we intended to show, mu nu k, is simply equal to, well, this doesn't have a prime attached to it, so we'll just the x alpha, the x prime tau, the x prime rho, the x mu, the x prime beta, the x nu, the x prime gamma, the x k. And looking at this also, we could say that this is prime attached to this, or this would be tau. Yeah, tau following, because of course I could have rewritten that. So this will become rho beta gamma. And this gives you the transformation law for this object, which we already intended to show. So indeed, what we have already known from the beginning, or called the Riemann tensor, one of whose variants is this, is indeed a tensor. As you can see, it does really transform as a tensor. And this is quite a very good way to show one of the properties of any tensor or tensorial objects.